part. Okay, so we're going to continue from the same part, which is principal quantum number. So according to principal quantum number, we know that the n represents the principal quantum number and is directly proportional to shell, right? So atomic radius, which means as the number of n increases, the atomic radius also increases. Okay, and we can say that as a value of n increases, energy also increases from first shell to infinity, right? And it also tells us about the maximum number of electron designator, the maximum numbers of electron, number of electron present in an atom can be known by there's a formula for it, which is 2n square, where n is nothing but principal quantum number. Okay, wait, we know k is a first shell, l is second one, while m is the third one, and n is the fourth one. 2 remains same, and k is the first shell, n square, which means it has maximum 2 electron. Then the same for it, it can have 8 electron, 18, and same 32 electrons. So what does principal quantum number tell us? It tells us about the energy radius. Also, there's a number of n increases and is directly proportional to atomic radius. As n increases, atomic radius also increases, and the energy also increases from one shell to infinity. The maximum number of electrons present in an atom can be known by formula, which is 2n square, where n is nothing but the principal quantum number. And about the shell that was for second ten is designated by k, l, m, n shell. So this is all about principal quantum number. Now we're gonna discuss about one more quantum number, that is azimuthal quantum number. As I said before, that azimuthal quantum number is also known as subsidiary or angular momentum quantum number. Momentum quantum. What does it tell us? It usually identify or tell us about shape of orbitals or subshells, sub-energy levels, right? The third thing is angular momentum. Momentum and energies in subshell. Okay, what is azimuthal quantum number? Here I can make a chart here so that we can have an idea. Before moving ahead, remember one thing: number of shell is always equals to number of subshells, right? Before moving ahead and discussing the azimuthal quantum number formula, let me tell you one thing. We can write here a shell, subshell, value of L, which is azimuthal quantum number, right? And the formula is n minus 1, where n is nothing but principal quantum number. First is k shell. First shell, I said that number of shell is always equal to number of subshell, which is k shell, which means it can have only one subshell, which is S. And what's the principal quantum number here? N. This is a first shell. Remember, this is first shell, right? So 1 minus 1 is equals to 0. Okay, so this is 1 minus 1 is equals to 0. So azimuthal quantum number of the first shell, which is k, and the subshell S, is 0. Let's move to the second one. M. Second shell, you can have 2 subshells. The first one is S and P. We are now known about that azimuthal quantum number of S is 0. Now we're going to find about P. N, which is 2 minus 1, 1. So what's the azimuthal Compton number of P. This is azimuthal Compton number of P is 1. Let's move to the third one. M. This is third shell and it can have 3 subshells, S, P and D. We are known about S, we are known about P. Let's move to the D. D is the third subshell. 3 minus 1 is equals to 2, which means that it can have the azimuthal Compton number of M is 2, and so on. The same series we're gonna follow. So I can write here for your convenience like azimuthal Compton number, azimuthal Compton number, azimuthal Compton number 0, 1, 2, 3. This is for S, this is for P, this is for D, this is for F. Remember one thing, for principal quantum, we start from natural numbers, and for azimuthal from whole number. This is a technique that we can remember, so it will be easy for us to understand. And one thing more, what does azimuthal quantum number tell us about? Now you can easily interpret that what does inside azimuthal quantum number tell us about, because I have explained everything, right? Number of subshell number. What does mean by subshell number and subshell number? This is number of subshell. 1 subshell, 2 subshell, 3 subshell, and subshell number is this 0, 1, 2, and so on. So on this thing we can be known about number of subshell and subshell number by this process, right, that I have just done here. So I remember one thing, this is the key point, number of shell is always equals to number of subshell. I can write here as well like 0, 1, 2, and 3. Number of subshell, like S can have only 1 subshell, K has 1 subshell, then P has 2 subshell, D has 3 subshell, and so on.